Hello everybody, my name is Mike Geig, and welcome to another live Unity session. Today we will be talking about 2D controllers, 2D animation, and the new 2D toolset. We have quite a bit of lag here because we have smashed our previous record and we now have a little over 1,100 people in here. So I'm noticing just a little bit more lag than I normally get. So if you're watching, I do apologize. Not a whole lot we can do about that. It's just kind of awesome that so many people showed up. So fantastic, and I'm really happy with the turnout. So good. Before we begin, like always, if you have any questions, comments, suggestions, anything like that, feel free to follow us on Twitter at Unity3D, at Mike Geig, which is me, at Will Goldstone, and at The Ant Ranch. Cool. All right. That being said, there are a lot of people in here today. I'm actually very, very pleased with the turnout, so thank you all for showing up. That being said, chat is going to be very, very difficult for me to read. All right, there are a lot of people in here. There are a lot of people talking. So if you ask a question and I don't see it, I'm not ignoring you. I just really can't see it because a lot of people are talking. Some people are saying that they can't see the video. If someone wouldn't mind mentioning in chat that if you can't see the video, you have to refresh the page. Sometimes that happens with some people and you just refresh and you should be able to see the video just fine. All right, so let us talk about 2D. Okay, so the 2D tools as of Unity 4.3 make it really simple to build 2D games in Unity, right? A lot of you maybe have done 2D games before, but this is something new and it's kind of a new workflow, and so we're going to talk about that. The focus today is going to be on animation specifically and building a 2D character controller. So there's a lot of stuff we can do with 2D, but we're going to kind of focus on that because that's kind of where a lot of people get the most held up, right? Is with the animations and stuff like that. And once you really get the animations, the rest just sort of falls in line, and it's all really fairly simple. So what we have here is we have the Unity screen open, and a couple things have already been done, and I'm just going to walk you through that. The first thing is that I have a folder here called Sprites, and I've got one sprite in it. It's a PNG file. You can see a preview of it right here. That's it. And another thing that's happened already is I've created this as a 2D project, right? Which means when I created the project, I just selected 2D instead of 3D from the dropdown. And the effects that has is this. If you go into Edit, Project Settings, Editor, you'll see that my default behavior mode is 2D and not 3D. Furthermore, my camera is orthographic with a size of 5. And finally, my scene is in 2D mode. Now, if I click this, all right, I can hop back into 3D mode if I want, or I can go back into 2D mode just by clicking this 2D button right here. So that's really the big difference of what's happened so far in the scene. So you really didn't miss anything there. And one other thing I've done is I've gone to Edit, Project Settings, Physics 2D, and I've changed the gravity to be 30. It's normally negative 9.81. And in this case, or it might be 9.81. In this case, I made it negative 30 to just make it a harsher gravity because 2D games tend to have stronger, faster gravities than 3D games, and we'll look at that. You'll see exactly what I'm talking about here, as I go through it. So that's what you've missed so far. And so what I want to do first is I am going to just set up a real simple test level that we can be doing all this stuff on, and which is why I have this sprite here. I really want to show you how easy it is to bring your sprites into your scene. So this is actually an image, right? Which its texture type is sprite. All right, that's another thing. If you set your project up to be 2D, all textures will come in as sprites instead of textures. I can still make it any of these, but it comes in as a sprite. And so I'll just click and drag it into my scene. And just a bit of ground there, and I've got my camera to set up, so I'll set it kind of like that. And it's a sprite, and it's going to be my ground, so I want to put a collider on it. And so all I really need to do is go Add Component, Physics 2D, Box Collider. Now, it will automatically take up the size and shape of the sprite. right? So I don't need to resize it or any of that junk. It's just there, and that's that. I mean, I can play my scene if I want, and you know, I've got this ground now, and it's walkable and everything like that, and that part's, you know, pretty straightforward. All right, so at this point, I'm gonna do one more, so that later when we do jumping, we have something to stand on. So I'll set another one up like that, and I'll add a box collider to it. Fantastic. Now I'll just leave the rest of these alone. So my scene kind of looks like this, and we're ready to go. So at this point, basically with 2D, all we're really doing is dealing with sprites. Okay, I mean, we can put 3D objects in there, and 3D physics and boxes and all that stuff, but really, we just need to work with sprites, right? I don't know if any of you have done this before, if any of you have made games in a time where you had to use code to actually animate your sprites and flip through the different sprites and stuff like that. That's where I came from. I came from a time where either primitive graphics or sprites in C++, and we wrote code to flip through these things, and it was a pain, right? Getting timing was a pain, getting your different animations was a pain, and you'd save instruction sets and stuff like that. It was a complete pain. And so now these things are very visual, and they become really, really simple. And even before Unity 4.3, if you didn't use like the 2D toolkit or something like that, you might have been writing code to flip your textures and stuff like that. So now we can actually make this, you know, make this really interactive and really, really simple. And so what I want to do is I'm going to go ahead and create an empty game object that's going to be my character, and I'm just going to add to it and build on it and stuff, and we're going to see how quickly we can get an animation to play and kind of get some of this stuff in the scene. And so what I'm going to do is I'm going to create a game object here, and I'm going to create empty right there. And it's just an empty game object, right? There's nothing to it. And I will rename it character. So I'll spell it correctly. I always apologize for my keyboard. No one ever really seems to mind, but I have a really loud keyboard, so you all get to listen to me just hack away at my keyboard, because I'm a very angry typer. And so it's like I hate my keyboard, so I attack it when I type. So I apologize for how loud that's going to be for you guys. And so I have my empty game object here, and there's a couple things I want to do to it to get it ready. And the first is that it needs to have some visual component, right? We have to be able to see it. And so I'm going to go to Add Component, Rendering, and I'm going to choose a Sprite Renderer. And that's just going to allow me to draw some image, some sprite, right? I'm also going to add component, physics 2D, not just physics 2D, that's a new section, physics 2D, and I'm going to choose a rigid body 2D, not rigid body 2D. All right, that's a specific type of rigid body. And I'll put that on there as well. So the rigid body 2D is going to allow me to use 2D physics with it, which is a great way for us to work with it. We could just use like translation to move our characters around, but then they won't be able to interact with objects physically, right? They won't be able to collide and push and things like that. So using a rigid body is much better. And a couple things we want to do here. The first is that we want to set fixed angle, and we want to check that. And the reason we check fixed angle is so that our character doesn't fall flat on his face, right? It prevents our rigid body from rotating, right? Which is what we want, because it's going to be just basically standing on its feet, and if it gets pushed or whatever, it'll fall right over. And we're not making quap, and so we basically don't want to do that, right? We want our characters to stand up straight, regardless of the physical forces. And we can animate any falling down and stuff like that we want. Another thing is our interpolate. We're just going to set to interpolate. And we'll leave that basically as it is. And I don't really need to mess with anything else in my rigid body. I'll leave everything else exactly the way it is. And I'll just collapse it down because I don't necessarily want to see it anymore, because it's all pretty much set up. So at this point, we have the fundamental container, right? Where all this stuff is going to be. For everyone, so I am checking chat here. Everyone's asking if this is going to be recorded. Yes, this will be recorded. I will be sure to have the link posted. I'll tweet it. I'll put it on Facebook. You guys will see it. I assure you will know. It'll be in the archive section. So yes, this is being recorded. Just answering that right now because I see a lot of people asking that. I record all of my sessions, so they're all available. So yeah. Okay, so we have this fundamentally ready. Okay, so now all we really need to do is we need to pull in some sprites. And so I have a folder right here that's got a bunch of different sprites in it. All right, these were done by one of the artists here at Unity. I believe Damien. I believe his name is Damien, or at least that's the name I think he goes by, Damien. But yeah, so he made these, and I'll show you what they are. These are sprite sheets. So if I open one, what you're going to see is it is a single image with a bunch of frames of 2D animation in it. And these are called sprite sheets, effectively. They're sheets of sprites. And so we have this one for idle. This is the entire idle, all right, sequence. This is what the character looks like when he's standing still. And that doesn't seem like a lot of motion. But it is very small, basic animations and stuff like that. Another real quick thing too. I don't want to keep getting sidetracked here. The people in chat that are basically being jackasses, stop or I will ban you. So, sorry, I don't like doing that. I'd really rather just talk. But if you're being detrimental to everyone around you, I'll just kick you out, and that'll be that. Okay. Anyway, so these are our sprite sheets, and so this here has all of my animations and stuff like that in there. And so I'll go ahead and close this, and basically what I'm going to do is I'm just going to click and drag the whole sheet and drop it into my sprites folder. Now, Unity doesn't necessarily know that this is a sprite sheet. All right, Unity just suspects that this is a single image, and so when I click this arrow next to it, it just shows me the image itself. So I can tell Unity that this is actually not just one image, but a whole collection of images. And this is where the powerful Unity tools comes in. This is where it gets really fantastic, all right? Because we're able just to say, hey, Unity, this one image contains all these other images, and then Unity will allow all this stuff to work. Another question that's in chat, where will these assets be available? These assets are not available yet, so there's no place to download them. Really, I didn't want you guys kind of playing around. Just wanted you to watch, and if you have your own assets, feel free to use them, but I kind of want this to be more of a generic, like, hey, this is kind of how you do all of these things, not just how you do these specific things. So, so yeah, we're not actually providing the assets for this. Sorry about that. All right, so we want to be able to tell Unity that this one sprite actually contains a bunch of different sprites. And so when I click this, all right, I get a lot of options here, and there's a lot of power here that you may not realize. And so this texture is coming in as a sprite, and here's its pixels to units. If I want this image to be smaller, I'll make this number bigger, and if I want the image to be bigger, I'll make that number smaller, because that's how many pixels in the original picture equate to 1 unit. In game, so just so you know what that does. And then we got our filtering modes and our normal stuff here. But what I want to do is I want to tell it that this is not a single image. This is in fact multiple images. And if I click multiple images, I get this thing called Sprite Editor. All right, Sprite Editor, when I click this, allows me to cut up and slice this sheet. All right, and so this window opens up here. This is our Sprite Editor. And before I continue, I just want to make sure that pops up. I'm watching the Twitch channel as well. I want to make sure that that actually pops up and you guys are able to see it. There's a little bit of a lag, so I have to wait a second here. Sorry about that. Okay, so it does look like it popped up. All right, fantastic. And so here's my Sprite Editor, and I have a couple ways I can slice this up. And slicing is just basically calling out each of the individual frames in this sheet. And so what I'm going to do is I'm going to click the slice button right up here in the corner, and I have this option to do automatic slicing. And if I do automatic, you can see that it picks out all of the different frames, but it doesn't actually line them up correctly. So we don't really want to use automatic. Automatic is not for when we do frame by frame animations. It's for pulling different elements out, right? So this is not what we want here. Instead, what I'm going to do is instead of automatic, I'm going to choose grid, because this particular sheet was set up in a grid fashion. Now, if you're an artist, you'll need to pay attention to how you're putting these sheets together. If you're not, and you get these from an artist, you'll need to ask them how it's kind of put together. And so what I want is, in this particular case, the sizes are 275 by 275. Your mileage may vary. It depends on the sprite sheet. Different sprite sheets use different sizes. This one happens to use 275 by 275. And I'm going to click slice, and I'm going to see that it manages to pull out each one of my frames. All right, they're each highlighted. All this stuff around here just gets discarded. I don't care about any of that stuff. Right, it's just blank space. All right, and then I will click apply. And now what we're going to see is that this one sprite is actually treated as a whole bunch of sprites, right? So if I click the arrow next to our sprite here, and I see each individual element of that sprite sheet. All right, so this is what's really cool. It is now allowing me to deal with all the individual elements of this sheet as opposed to one whole sheet. Okay, so that's a really powerful feature, and you may not realize how awesome that is. But if you've ever actually done the hard coding stuff and realize how bad it sucks to have to like write in all these coordinates and keep the arrays of those coordinates and stuff like that, this is actually really, really awesome. And this is going to allow me to do one more thing too. And what this is going to allow me to do is I'm going to click on my character right here, who has no image to him, and I'm just going to grab the first frame of idle, and I'm going to drop it in the sprite slot, and there we go. This allows me to kind of place him how I want and see how big he's going to be, and so on and so forth. Some of the questions: yes, you can import sprites from Gimp. This was just a PNG file. It doesn't really matter what size or what format the file is, as long as it's one that Unity could read. And then when I sliced this up, 275 by 275 was each frame of this. The whole image was like 248 by 248 or something like that, or 2048 by 2048. So it was much bigger. So 275 was just each image, including the white space. The white space is pretty much going to be ignored though, so it's not really a big deal. Like also, if you ever did 2D programming, you would have to keep track of a bounding box inside, because otherwise you'd be colliding with empty space and your colliders were off, and it was a total pain, right? So this is much simpler, okay? I'm also going to tell you this right now. The way I've done this is going to lead to a pretty big issue in a second here. So I've actually done this wrong, and I've done it wrong intentionally so that I can show you how to fix it, all right? Because you're going to notice something here in a second, and this might happen to you, and I want you to know, okay? Also, someone said, do we really need to have sprite sheets? Are we good with separate PNG sequences? You're fine with individual PNG sequences. I don't recommend it, but whatever, right? It's just easier to manage a single file. But if you don't have a sprite sheet, then don't use a sprite sheet. But if you've got a bunch of individual images, just throw them together into a sheet, and then you're good. So yeah, so you have that. Okay, so at this point, we're ready to go. I'm going to run my scene, and you're going to see what's happening. Oh, that was fun. That was quite a fantastic experience. We have one more thing that we're missing here. Sorry, one moment here. I had to ban someone from talking. There's one more thing here that we're missing. And what we're missing is colliders on our character, right? Our character has a rigid body, but no colliders, right? And the reason we didn't add a collider earlier is because we didn't know what the character would look like, right? I could add a box collider, but that's not very precise. So now that I have my character sprite in here, right? I'm going to go ahead and add some colliders. And so what I'm going to do is, with my character selected, I'm going to add a component, physics 2D. Now I'm going to first add a circle collider. All right. And the circle collider is what I always put on the feet, and I put a circle collider on the feet so that the character can go up hills and stairs and things like that smoothly. If it was a box, any incline, it would get stuck. Or if there was a little dip in the ground, it would get stuck, and that's always super annoying. So for the feet, we do a circle collider. And I'm just going to go ahead and change my radius here a little bit. That's pretty good. And lower it down to where it's just right about there. Good. So yeah, so we have our circle collider down here at the feet, just like that. And now, since we want accurate collision kind of up here, I also want to add another component. And in this case, I'm going to add a box collider. We could do a polygon collider. The polygon colliders is actually pretty slick, but they're less efficient than a box and a sphere. So if I can just use a box and a circle, I'm going to use a box and a circle, right? Because efficiency is the name of the game. And so I'll just bring that in right about here, and right about there. And bring that down about there. Maybe raise it up, touch. There we go. Okay, and so now we have colliders, all right? We have colliders here. We got a circle collider at the feet. We got a box collider for the rest of the body. And I will just hit play now, and we see our guy land safely. All right, so there we go. pretty straightforward, just like that. Okay, so now we've got our character in the scene, and we have the colliders. We have a circle collider for the feet, so it'll be able to more easily traverse terrain, and we have a box around the rest of the body because that'll be accurate enough collision detection. We could do polygons for very specific collision detections, but we're not going to. Someone in chat says a 4 vertex polygon colliders is as efficient as a box collider. That's correct, but if it's a 4 vertex polygon collider, then it is a box collider or a rhombus collider, and it will be not any more effective. So I guess we could get skewed shapes with a polygon collider using only vertices, but if we want it for more accuracy, it's going to be less efficient, which is kind of what I was getting at. Alright, so we have our colliders, so I'm just going to go ahead and minimize those here. We know they're there, that's all we really care about. So let's go ahead and build an animation, okay? Now that we have it visible and stuff like that, let's get our idle animation ready, okay? And like I said before, there's going to be an issue, and I'll show you what it is, and then we'll fix it, right? Because a lot of you are going to have the same problem. And so what I'm going to do is, first things first, I have to create an animator component for this guy. The Mecanim system uses things called animators and animator controllers to manage the states of our different animation. So I'm going to add component, and I'm going to come down to, where is it at? Miscellaneous. And I want an animator. An animator, just like that. And a couple things I want to do. Avatar is going to be blank. We don't want an avatar. I'm going to uncheck apply root motion, and I'm going to check animate physics. Okay, no root motion in 2D. Okay, instead we're going to animate physics, which will keep our character's animations in time with the physics engine. Since we're using a rigid body and since we're using velocity in physics, we want to sync our animations up with those physics. All right. One question here. Are there any issues when the colliders of the same game object intersect with each other? No. I say that questioningly. I've not encountered an issue with that. I do it. If that's not the case, I don't know what it is. I don't know if there is one. So I'm going to say that having overlap, and what they're asking about is how my colliders overlap right here. I don't think that's a problem. It's not been a problem yet, so I'm going to say no. But if someone proves me wrong later, then just know that it was a guess, and I might be wrong. Okay, so uncheck apply root motions, check animate physics, calling mode we can leave the same, avatar's going to be blank. We want to create a controller that's going to go ahead and manage the animator here. All right, so we need something right here for this animator. And so to do that, I'm just going to click out of my sprites folder, just kind of anywhere in the project view, and I'm going to right click and go to create animator controller, right here, animator controller, and I'll call this robot controller, just there. You can also click this create menu here, and animator controller's right there, doesn't really matter. And so with my character selected, I'm just going to click and drag my robot controller into there, and there, that's linked up. So now this character has an animator that's controlled by this controller, and that's how they're linked together. All right? Yeah, animator, not animation. We're going to be dealing with both of those. Someone mentioned that in chat there. Okay. And if I double click on our animator controller, I get this animator controller window. All right, which I'm immediately going to click and drag down here to the bottom, because that's where I work on it. And I'll make it a little bit bigger. Everyone has their own workflow. This just happens to be my workflow. Some people put them wherever they want. Yeah, I'll show you. So that is our animator. And our animator only has one state right now, and that one state is our any state, which basically represents any state, right? Makes sense. So now, what I want to do is I want to create an animation that we can apply to our animator. All right, and this is again where the visual components come in, and where this is quite fantastic. So I'm going to go ahead and open my animation window, which is not open by default, by going to Window, Animation, or hitting Control-6 or Command-6 on a Mac. And I get this animation window, which I'm going to go ahead and dock at the top right here. Okay, so we have our animation window, we have our animator window, all of these things are open. Now we're ready to begin here. So it's important to have my character selected before doing any work. If I do work without my character selected, the animations may not be created correctly. All right. And so I'm going to click character, right? So now the animations that I create will be for my character, for this animator controller. All right? Yeah, I'm emphasizing the animator so people don't mistake what I'm saying. And so what I'm going to do is I'm going to click this drop down right here. It's kind of small, it's kind of hard to see, right next to the word sample, and I'm going to create my first animation. All right, by clicking here and clicking create new clip, which will bring up this dialog right here in my assets folder, and I'm going to create a new folder, animations, and then inside there I'm going to create idle. Now a couple things happen. All right, the first is that our idle animation is up here. Our second is we get an idle down here in our animator, right? This happened automatically. Also, because it is orange, that tells me that this is the default animation. This is the default state, all right? Otherwise, you know, we won't have a default state. So the orange one is always the default state. So this guy will be defaulting to idle, which is exactly what we want. So now let's go ahead and set up this animation. I'm going to come back here to project. I'm going to go into my sprites. I'm going to expand idle. I'm going to click idle 0 and then shift click all the way to idle 29 to select all of them. And I'm just going to click it and drag it up there to the top. All right, so all of these frames are all up here. I'll also change my sample to 24. I only do that because the animator that created this, the artist, I'll say artist so we don't confuse animator, the artist that created this set it up to be 24 frames per second, right? So I'm just following what he set it up as, right? If I wanted to speed this up, I'd make that number higher. If I wanted to slow it down, I'll make it lower, right? But 24 sample size. All right. And so I don't need to do anything else. Idle is my default state. All right, it has the idle animation already in it, okay? And the idle animation has all of these frames. So let's go ahead and run our scene. Now a couple things we see. First off is the character is animated. The character is playing his idle animation. The second thing we're going to notice is the character looks like crap. All right, I don't know if you can see it being on Twitch. I don't know if the quality is very high. But he's shaking, he's kind of fidgeting and swinging, or and the image quality is very low. And if this is you, if you made this, you might be sitting there at home going, what is happening? Why does this look so terrible? My sprites look fine, what's going on? And so this is that problem I told you we were going to have. And the problem is actually something with how we imported it, right? So let me stop playing this, and I want to show you something. So here's my file. I have it selected here, and I can see my dimensions are 2048 by 2048. All right, since it's a sprite sheet, 2048 by 2048. But when I come back in here and I click on my idle PNG sprite, my maximum size is only 1024. The result is Unity is shrinking this down, and we're becoming pixels off, single pixels off, just very tiny amounts off. And the result is that the character shakes and looks like garbage and stuff like that. So let me show you this. Let me zoom in real close here. I want you to look at the quality of this image, the quality of this sprite, all right, when I change this to 248. Look how much better that becomes. All right, immediately that becomes much, much higher of quality than it was before, right? And I'm going to zoom back out now, right? And I'm going to go ahead and play it now. And we see that it is now a nice, smooth animation, right? No longer any issues there. This works out quite nicely, all right? So there we go. So that makes a significant difference. It's important to pay attention to the size of the images and the max size that you're allowing it to have. Sprite sheets tend to get very big, right? Especially if you're dealing with high resolution pieces of art, right? And so we need to make sure we're dealing with the right size. So yeah, now the animation is much better. He's just sort of slightly idling. Yeah, so it works much, much better. Okay, so one moment here. Taking my drink of water. well deserved, I suppose. All right. Now, okay, so we've got this little idle dude, right? And that's all well and good. But it's a boring game. No one wants to play Idle Quest or Idle Quest 2, Son of Idle Quest, or anything like that, because you know, standing still is kind of boring. So what we now want to do is we want to attack the keyboard. What we want to do is we want to create some more animations, and we want to create some more controls, and we want to actually do something with this character. So what I want to do is I want to set up a run animation. Luckily, I have a run sprite sheet right here. So what I'm going to do is I'm just going to click and drag it down in here into Unity. There we go. And I'll click run, and of course we're going to go through the same process. I'm not going to be fooled this time. I'm going to set it up to be 248 in size, and I'm going to set this up to multiple and hit Sprite Editor, and I'm going to slice it on a grid, and of course it is 275 by 275, and I'll hit apply. There we go. Okay. So now this image is in here with all the individual frames, which again, I'm going to point out is really powerful. Like, you don't even know. Like, you guys have no idea how awesome that is if you never had to do it the old crappy way, the old by hand way, which really, really sucked. And so, yeah, that's awesome. So trust me when I tell you that's awesome. Okay. So let's go ahead and create another animation, which we will link in our Animator, all right, and we'll create our transition. We'll start putting this thing together. The cool thing is the Animator Controller just manages all these states for us, right, and allows, you know, a lot of really useful things, all right. So let's take a look at that. So I'm going to click my animation window here, make sure my character is selected, and in this drop-down, I'm going to click Create New Clip. And I'm going to get in my animations folder, and I'm going to say run. That's my run animation, and I'm just going to grab all of these, drop them right there. My sample size is 24. That animation is done. That animation is completely fine, automatically for you. How awesome is that? The whole animation done, right? Brought the sheet in, sliced it out, made the animation, finished. I can come back to my scene view. Don't even need to mess with that. All right, and so that's pretty cool. So now that we have that, let's go ahead and link it up. If I come to my Animator, I will see that run is here automatically because I created the animation. It's done automatically. So one of the questions in chat: do you not have to select the character? I did select the character. I selected the character when I was in the animation window. Which allowed me to do that. So yeah. Let's see. I'm sorry. I'm just reading through chat here real quick. It's going really, really fast. So yeah, I'm trying to keep up with anyone asking questions. So yeah. Anyway, sorry about that. I'm not ignoring your questions if you're asking questions. I promise you that. But there's just a lot of people. So okay. So we have our idle, which is our default animation because it's orange. And we have run, which is our non-default animation, and it's gray. And so what I want to do is I want to control when one animation plays versus the other. I want to show you something here. So I'm going to run this. And I want you to see how down here we can see that the idle is running. All right? Notice that we're never transitioning anywhere else. Idle is continuously running. So what I want to do is I want to tell my Animator Controller when to switch from this animation to this one. All right? And in order to do that, I'm going to utilize something called a parameter. And a parameter is basically like a variable that I can use inside the Animator Controller. And a very common one is one called speed. So in my parameters, I'm going to hit this plus sign right down here. And I'm going to choose a float. And I'm just going to name it speed. Just that simple. We have a speed, a float named speed. And then I'm going to right click on idle and click make transition. And I'm going to click run. Then we get this line here. And so basically what I'm going to say, when I click on this, I'm going to say, go from idle to run when speed is greater than 0.01. That's it. So now, whenever speed becomes greater than 0.01, my character will start running animation, right? That's it. That's how simple it is, all right? Now, I'm going to right-click on Run, and I'm going to make a transition back to idle, and I'm going to click on that, and I'm going to say, hey, go back to idle when speed is less than 0.01. That's simple, right? So now, if my speed goes up, my character goes to running. If my speed goes down, my character comes back to not running, right? Back to idle. That simple, okay? Now, all I really need to do is, in my code, when I move, pass that into speed, all right? So one of the questions, can you make a Boolean animation variable? So there are 4 types. There's float, int, bool, and trigger. And a trigger is like a bool, but it'll become true and then immediately false again. So it's like great for jumping and stuff like that. All right. So those are the 4 types there of attributes. I'm sorry, I'm just reading through some stuff here. So Rzibu asked, what if you want to apply the same template character and just change the sprite sheets? Can you do that for enemy, or do you have to start from the beginning? Actually, you can reuse this stuff. So basically, this controller can go on anything, right? And then all I really need to do is just change the animation in here. It's actually really, really simple. And so you can very easily make a templated controller, just swap in new animations, and that's it. Right, and it's all done again. The neat thing is this, is when I click on this character and I see this idle 0 sprite here, we don't ever really see that sprite. We see the animation. The only reason I put that sprite here is so that we can see it in the scene view, so we can put the colliders on there and stuff like that. But even without that in there, if I were to remove this and run it, we'd still see our animation, right? We only put that in there because it makes it simple to see it for testing. So I can put any animations I want into this controller and it will become any character, right? So yeah, it's really, really straightforward. Okay. I believe an X&A conversation has broken out in chat. It would be very helpful for me if you guys would kind of stay on topic there, because people are trying to ask questions and I won't be able to see them. Anyway, okay, so we've got our idle, we've got our run, we've got our transition set up appropriately. We'll go to run when speed is greater than 0.01. We'll go back to idle when it's less than 0.01, and we have our speed parameter. All the stuff inside Unity, and let me save my scene here. Always a good idea to save my scene in case something bad happens. So all that stuff is done in there. Let's go ahead and write ourselves some code that's going to go ahead and make this better, or make this all work. So here in my project view, I'm just going to create a new folder called scripts. And inside there, I will create a new script, which I'll just call robot controller script. Why not? Robot controller script. And then, so basically this script is going to do 2 things. This script is basically going to be responsible for moving my character around and also for telling the animator what the parameters are. Now this script will not be responsible for telling the animator how to animate. This script will not be responsible for telling the animator what state it's in or anything like that. This script will basically just be updating some parameters, right? And so I'm going to go ahead and open this here. And give it a second here. The new mono develop is a little bit slower than the older one, so it takes a second to open up. I don't know, a lot of people like the new mono develop. I really liked the old one. I'm not a huge fan of the new one, but yeah, what are you going to do, right? That is what people wanted, so that's what people get. And so a couple of things we want to do here to control this. So what I'm going to do is I'm going to teach you how to move, right? And then I'll teach you how to link up the animation, right? Because they're kind of 2 separate things. So first thing I'm going to do is I'm going to create a couple variables here. So the first is going to be public float max speed. We'll set that up to 10 by default. And this is going to just be how fast the character can go at maximum, right? The max speed. All right. And then we need a private variable bool, which is going to be facing right equals true. This just tells us which way our character is facing. Now, basically, there's a couple ways we can do facing left and facing right. I mean, realistically, you can create a series of animations, both with the character facing left and both with, both with the character facing left, both with the character facing right, and jumping left and jumping right and crouching left and right. And we can do all these different facings and stuff like that, right? And that's, that you can certainly do that. It gives you a finer level of control. But we can actually do a trick where we just change our local scale and flip our characters, which saves us from having to do a lot of the other animations, right? It saves the artist a lot of time. All right, and so that's what we're going to do here. We're going to make it so we only have to deal with one specifically. And so what I'm going to do is I'm not going to work with update. I'm going to work with fixed update. And you'll remember that I'm using a rigid body, and I chose to animate physics, which means my animator is going to be in sync with my fixed update. So I'm going to do most of that stuff in here. All right. And so what I'm going to do is I am going to, first off, I'm going to read in how much I'm moving. So I'm going to say float move equals input dot get axis horizontal. I'll get the horizontal axis. So this is just raw input. This is how much we're moving, right? And then I am going to say, I'm going to go ahead and move my character by saying rigid body 2D, not rigid body 2D. Okay, rigid body 2D dot velocity equals new vector 2, right? We're not dealing with vector 3s now. This is 2D stuff. So vector 2, and then we are going to pass in move times max speed. All right, so how much we're pressing the buttons times our max speed, and then comma, and then we'll pass in our current rigid body 2D, lowercase rigid body 2D, dot velocity dot y. So we're taking our current y velocity, since we're moving left and right, we'll just keep the y velocity the way it is, and then we'll just move left or right based on what key they're pressing times the max speed. Now, someone asked, do we need to use time.delta time? The answer is no. If we're in fixed update, we do not need to use time.delta time, because time.delta time happens at the exact same time step. Okay, normal update, or I'm sorry, fixed update is handled at the same time step. Normal update can fluctuate, fixed update does not. And so we do all our physics stuff inside fixed update, and so I don't need to use time.delta time. All right, so that's why I'm using fixed update instead of update for physics stuff. Okay, and then basically I'm going to create a new function. So I'll come down here called flip, void flip. And what I'm going to say inside flip is I'm going to say facing right equals not facing right. So it just flips our facing, and I'll show you how we're going to use this. Facing right equals not facing right, and then vector 3, the scale equals transform dot local scale. The scale dot x times equals -1, and then transform dot local scale equals the scale. So whenever we flip this, all right, whenever we flip this, we're basically saying, hey, we're facing the opposite direction. We're saying, let me get the local scale, let me flip the x-axis, and then apply it back to local scale. So all we're doing is we're taking the world and flipping it 180 degrees, right? Which means I no longer need a left and right animation for facing left and facing right. I'm flipping the world, and thus the animation will also flip. All right, and so we get to save ourselves a ton of animation. So all I need to do is link this in here now. And so what I'm going to say is after we move, I'm going to say if move, which is the input we get here, if move is greater than 0 and we're not facing right, flip. Else, if move is less than 0 and we are facing right, flip. That's it. All right, so if we're moving in the negative direction, if we're moving to the left and we're facing and we're not facing left, right, flip it. And if we're moving to the right but we're not facing right, flip it. And that's basically it, right? That makes it real simple there. Okay, so this does not have any of the animation stuff plugged in. This is real just basically moving our character around. And that's all this does. So let's go back into Unity and see what that does. So I'll grab my robot controller, I'll click and drag it onto my character, right? So we see it right here, max speed is 10. I'll hit play. And, okay, so I'm moving around. Okay, now, that's great, but I have an animation for this. And I can make this animation run very simply, all right? And so what I'm going to do now is I'm just going to hook in my animation, right? And so my animation plays. Remember that this still exists here. All I need to do is change speed. I don't need to do anything with this. I change speed and this all just magically happens, all right? And I'll actually leave it there. So let me go back into my script, and all I need is a reference to my animator, right? Which I'm going to say animator, and we'll just call it anim. And in my start function, I'm going to say anim equals get component animator, just like that. And then after I get my input, I'm simply going to say anim.setFloat, and the float I'm setting is speed, and what I'm setting it to is mathf.absolute_value move. That's it. So basically, we don't care if we're moving in the positive or negative direction, which is why we do absolute value. So if I'm moving 1 or -1, it'll just be passed in as 1, right? That's it. That's all I'm doing here. This controls the whole thing. I'm just setting speed, okay? I'm letting my Animator controller handle the rest of that. I am not interested in handling any of that. So with this one line of code, obviously plus the variable and getting the animator, this one line of code though, I will run my scene, and my guy runs. It's really laggy because I'm recording the screen right now. So I apologize for that. For those of you who are watching and you're like, man, that's really choppy. It's really, it's laggy because I'm recording the screen and I got so many windows open and everything like that. But if I keep running here, you'll notice how my run animation is cycling, right? And when I stop, it goes back to idle. Just like that. A lot of you were surprised by me not having curly braces in the if statement. If it's only a single line of code, I don't need curly braces. If it's more than one line of code, I need curly braces. So, yeah. So I'm not really trying to get into the syntax too much. But yeah, so there you go. So basically, yeah. So with this one line of code, by setting this variable, right, I am able to have a nice transition from one animation to the next. Now, this seems like I did a lot, right? There's a lot of steps here, but realistically, it's very, very simple, right? It's the same 3 steps always, right? Create the animation, add it to the animator, add a hook in your script. Create the animation, add it to the animator, put the hook in your script, right? Over and over and over again. It's actually really, really, really simple to do, and so it may seem like a lot, but it's not. All right. How am I doing on time? So I'm going to go a little bit over today. Normally I try to do an hour, but there's one more thing I want to show you, and it's going to take me a little while, but it's super important. I'm going to show you how to do jumps. And jumps are the things that people are always asking about, right? And so I'm gonna go over and I'm going to show you how to do that. So basically, there are a lot of ways to do jumps, okay? Jumping it depends on your game, depends on what you want to do, depends on all these different things. I'm going to show you one way. There are a lot of ways. I'm going to show you one way. And so basically, what we're going to do is we're not going to create a single jump animation. We're going to create 11 jump animations, and we're going to use a blend tree to smoothly animate between them. I could very easily create an animation just like I just did, right? An animation of the character jumping, and move the character up and then back down and have the animation play. And that's great, and that certainly works, and if that's the way you want to set up your game, more power to you, right? However, some limitations of that is what happens if they, land before they finish their animation. You got to cut it short, and what about how they're standing when that happens, and how does it transition, and what happens if a character is up on this part, right, and falls off, right? Do we want a falling animation? Do we just want them to just basically keep running off the side, right? And so, yeah, I mean, there's basically you know, there's a lot of different things we can worry about. So what I'm going to show you guys how to do is I am going to show you how to build an animation basically based on not being on the ground. Okay, so excuse me. Sorry, I had to cough. I'm not going to really show you how to play a jumping animation so much as I'm going to show you how to run a blended animation while you're not on the ground. Okay, and that may seem the same, but it's really not the same. So I'm not going to have like a jumping state or anything like that. I am only going to have a not on the ground state, basically. All right, and so what we're going to do is we are going to constantly check right below the character's feet to see if there's ground there. All right, and if there is ground there, then the character state will be grounded, right, and everything will be fine. However, the moment there is no ground there, the character will go into a falling state, okay, and in that falling state, we'll play a falling animation, okay, and that will basically allow us to do all sorts of things that a normal jump animation won't allow us to do. So it is important. I do want you to understand the distinction between a jump animation and what I'm about to do, because they're two different things. What I'm about to show you applies to falling and everything else at the same time. Okay, and so I'm gonna start this by working in script. All right, and I need some variables and stuff like that to kind of get started here. And so what I need, a couple of things. What I need is I need a Boolean to tell me if I'm on the ground. So I'll say grounded, and I'll say false because our character is starting just a little bit above the ground, so it's actually not grounded yet. All right, so we need that. We also want a transform for something called ground check. This is not a way you have to do it, but this is the way I'm going to do it. I'm going to create another object to represent where the ground should be to the character. It just makes this part easier. I don't have to do that. I could just hard code some values or have a vector in there or something, but this just makes it simple, makes it visual. And remember, visual is awesome, right? Because it makes things easier. Then I want float ground radius, and the ground radius, is how big our sphere is going to be, our circle is going to be when we check for the ground. And this will make sense here in a couple minutes. And I'm just basically showing you this now. And then finally, I want a public layer mask called what is ground. Okay, so basically, I need to tell my character what is considered ground, right? Because is water ground? Are bullets ground? Is our enemies ground? What can the character land on? Right? And stop animating a falling animation. And so we use a layer mask to say, hey, what is ground exactly? All right? We also don't want the character landing on itself. We don't want the collider reading itself. And so we're gonna fix that here. So these four things are going to set us up just to fall. Right? This is just our grounded stuff. All right? And then inside our fixed update, right? Before we do anything else, so I'll just move that down. Inside our fixed update, we're just going to constantly check, hey, are we on the ground? Hey, are we on the ground? Hey, are we on the ground, right? And constantly be aware of whether or not we're on the ground. And to do that, I'm going to take my variable grounded, which I created right here, and I'm going to say grounded equals physics2d dot overlap circle. All right, and this is just going to say, hey, are we hitting any colliders in this circle, right? And we're going to project it right below their feet, all right? And so the position is going to be ground check dot position, which is why I created that variable ground check. So I can just put ground check wherever I want, and that's where it's going to generate the circle. Makes it very visual. Ground check, ground radius, all right? And then my layer mask, which is what is ground. Went a little bit off the screen there, but you see ground equals overlap circle. This is where the circle is generated. This is the radius of the circle, and this is all of the things that it'll collide with. Okay? And this will return back to me true or false. Did it hit anywhere, or did it not hit anywhere? Right? Is there a collider there, or is there not a collider there? So if the result is true, we know we're on the ground. And if the result is false, we know we are not on the ground. All right? And so now I'm going to say anim for our animator. All right, set bool, which this is one we haven't created yet. We have to create it. Ground equals grounded. So this will, every frame, this is going to say, hey, we're on the ground or we're not on the ground, or we're on the ground or we're not on the ground, over and over and over and over and over, right? And so we'll always know if we're on the ground or not. And so now I'm going to save this, all right? And I'm going to come back into Unity, and I need to do a couple things. The first is I need to create an object called ground check. And I'll attach it to my character, or I'll nest it. And another thing I'm going to do with ground check is I'm going to click right over here where this box is, and I'm going to pick an icon. So that just allows me to see it better here inside the scene view. And I'm just going to click it and drag it to, let's see here, to 0, 0, 0. And now I'll just drag it down to right about where the ground should be. Just right down there. All right? Just, so now we can see that that's where the ground check is going to be. And if I click on my character, we see the ground check transform. And I'm just going to click the newly created ground checked object and drop it there. There. So now every frame, it's going to create a tiny circle around this object and see if it hits a collider. See if it hits this or not, or see if it hits this or anything else, right? Another thing I need to do is I'm going to take my character, I'm going to put the character on its own layer. I'm going to put it on a player layer. I know that rhymes. Player layer. All right. I created this already. I forgot that I created this already. So if you didn't have it, you could just click add layer and just type player into one of these, right? It doesn't matter. You can put it wherever. And so just put them on the player layer. It's going to ask if you also want to update ground check. Yes, you do. So now these are both on the player layer. The reason that's important is so that when I select what is ground, here's that layer mask I was telling you about, I want everything to be the ground except for the player. Because you don't want the player colliding with itself, right? That won't work. Okay, one last thing we need is we need to create our ground parameter, which is a Boolean. Okay, now that we have that, let's hit play. And we're going to see that, yes, we are grounded. You see the little check mark down here? And I'm running around and we're staying grounded. Now watch what happens to this check mark when I run off the edge. I'm not grounded anymore, right? And my character is free falling to oblivion. Okay? We now are able to detect whether or not our character is on the ground. And this is monumental for this type of jump. Other jumping, it doesn't really matter, right? Depends on how you set it up. But for this type of jumping, because we want to know we're grounded because we're linking our jump animation and our fall animation. So check this out. I'm going to take any state, right? Any state right here. And what I'm going to do is I'm going to link any state to my jumping falling, which will link back to idle. So any state, either from idle or running, can go to falling, right? So this will make sense here in a second, but I just wanted to show you that. All right. So we have all that stuff in there and set up. Now let's go ahead and set up our jumping code. And our jumping code is actually fairly simple. We're basically going to say, hey, if we are currently grounded, we can jump, right? I mean, that's it. That's pretty simple, right? If we're currently grounded, we can jump up in the air, right? If you wanted to have like double jump in your game, you might say if we're currently grounded or if we're only on our first jump, then jump up further, right? And so we could do double jump that way. We're never going to mess with that ourselves, but we could. So let me go back into our script. And so a couple of things I want to do. The first thing is in my fixed update, right after we determine our grounded, I'm going to pass in a variable to my animator again. Okay, and this time, this is one we don't have yet. We're going to create it here in a second. anim.setFloat. And this time we're going to set a float called vSpeed. This stands for vertical speed. We're going to tell it how fast we're going up or going down. And we're going to use that in our blend tree, right? So vSpeed, and we're going to pass in rigidbody2d.velocity.y. So every frame we're going to say, hey, this is how fast we're moving up, or this is how fast we're moving down, right? Real simple, just like that. We're moving up this fast, we're moving down that fast. Then we're going to do something inside our update, not fixed update, but update. All right, so I'm going to do void update. And the reason I'm doing this inside update is so that the input is read more accurately. Right? If I put this inside fixed update, the input of pressing the spacebar may be missed, and that's no good. All right, and so, and for a lot of people are saying, what about flying creatures? Just turn gravity off, and then you're flying, right? Yeah, whatever. You can. That's fairly easy to do. So for my jump, I'm going to say, hey, if we are currently grounded, and the player has pressed input.get key down. Now, I'm doing get key down, key code space. It's not a good idea to do get key. You'd really want to go to your input manager and create a jump axis or a jump button, right? And then you would just say jump, so it's remappable for the players. But I don't want to get into all that, so I'm just doing key code space. But just so you know, this is not a good idea. You should not do this. I'm doing this, so do as I say, not as I do. And so what I'm basically saying is when you jump, I'm going to say animation.setBool. We're immediately saying, hey, we are no longer on the ground. So ground equals false. We're immediately saying we're jumping, we're not on the ground anymore, and then we're just going to add some force. So I'm going to say rigid body 2D.add force, and I will pass in a new vector 2, 0 for my x and y, because I don't need any force along x and y. And then I'm going to pass in my jump force. I could create a variable. Well, I will create a variable for it because this is a good idea. So I will do public float jump force equals 700. There we go. And then I'll jump by jump force. There. Okay. And so basically here we're saying, hey, if it's grounded and we're pushing the space bar, we're no longer grounded and we're jumping now. Okay, and I am a parenthesis short. There we go. There, fix that. Okay, so now that's it. That's all the code I need to write. All right, I just basically say, hey, jump, and hey, we're not grounded. In every frame, hey, this is my current vertical speed. I'm done coding for the rest of today. All right, I can take a break and eat donuts and have a beer or whatever. And so now, everything else we're going to do is going to be here inside Unity. Okay. And so, someone said I missed a bracket. I didn't miss a bracket. No brackets are missed. I never miss a bracket. That's right. I'm too hardcore to miss brackets. Anyway, so now this part is a little tedious. Okay, what we're going to do is we are going to create 11 jump animations, okay? And it is a little tedious, but I'm going to show you that we're going to use those 11 jump animations and we're going to put them into a blend tree, and it's actually going to be pretty cool, okay? Because basically we're going to determine, based on our vertical speed, what animation to play. So I'm going to come back here to my project, into my sprites folder, and I have a jump blend tree PNG. So I'll click and drag that down. And with this one, we're actually not going to use a lot of it. Now I'm going to go back to 248, make sure I got my right size, and it is multiple. So I'll go to my Sprite Editor, go to Slice, Grid, 275 by, ooh, that's not right. 275, that's not right either. I can type, I promise. 275 by 275. Slice it up, hit apply. So a lot of people are asking about 700. 700 is just through trial and error, determined that that looked good. Remember, we did turn our gravity up to -30, right? And so basically, I want my jumps to be crisp, right? I want you to rock it up quickly and then drop quickly, right? Because this is a 2D game, and so the longer you float, if you don't have a lot of air control, right, it's easier to die. So I want my jumps to be very crisp and sharp. If I wanted them to be floatier, I would use a lower force and a lower gravity, and then you'd be very lofty, right? And so I don't want that. So that's why 700. I'm pushing you up really hard. Remember, this isn't impulse force either. This is regular force, so it's not going to be all that powerful. And gravity is pretty strong, so it'll be pulling you back down as well. So now I have all my jump stuff, right? And I'm not using a lot of these frames. I'm actually only going to use 11 of the total 26 frames. So what I'm going to do here with my character selected, right? In the animation, I'm going to go ahead and create each of these animations first, and then I'll go ahead and add the frames to them, right? So this part is a little tedious, so just bear with me. And so we're going to create 11 of these. Trust me, the result, it'll be worth it. Now, I don't have to do this, right? There are a lot of ways to set this up. This is just one of them, all right? But I find this way, it looks pretty good. And so if it requires a little extra work on my part, then it requires a little extra work, you know? Sometimes stuff requires extra work to look pretty cool. What am I at, 7? So how about that weather, huh? I hear it's very weatherful. Snowing in Egypt and whatnot. All right, and so we have 11 animations now. All right, and so that's boring, but check this out. So I'm gonna go to jump 1, and I'm gonna grab, what frame do I want? I think I want this frame. Or wait a minute. Yeah, so this is the frame I want. Actually, I'm going to grab this one. And so I just want a single frame, and I'll put that right there. I'll go to jump 2, and I'm going to skip a couple frames. Jump 3, again, skip a couple frames. And again, so all I'm doing is I'm doing single frames. You'll see what this does here in a second. It's actually pretty cool. I'm doing single frames, and I'm doing 11 single frames. And again, I could put these all together in one animation, but I'm going to have a much stronger level of control over the arc, over when it's interrupted, all of these things by not putting them together. All right. There we go. Okay, and so now I have 11 frames of animation, right, which are each all single frames. I'm going to click and drag on my animations now. I'm dropping them in the animations folder where they belong. And that's that. So now I'm going to click on the Animator, and I'm going to see a lot of animations that I do not need. Remember, they get automatically added for me, so I'm just going to delete them. I don't want any of these states, so goodbye. And instead, what I'm going to do is I'm going to create one state to kind of control all of my jumping. All right? So I'm going to right-click out here. Well, first thing I'm going to do is parameters. I'm going to create my float, which was v-speed. You remember that in code, where every frame we're setting our vertical speed? Now I have the parameter for it. And then I'm going to right-click somewhere out here in the empty, and I'm going to create a state from a blend tree. And so what I want this blend tree to do is I want it to pick which frame of the animation to play based on how fast I'm going in the vertical direction. So I'll say from new blend tree. All right. And I will transition to the blend tree when ground equals false, and I will transition to idle when ground equals true. And that's it. So no matter what state I'm in, when ground equals false, we go to, oh, I should name this, jump and fall. So whenever ground is false, we go to jump and fall, and then whenever ground is true, we go to idle. All right? And then from idle, we can go to run in all these different places. All right? And then so inside jump and fall, I'm going to double click this, and that's going to bring me inside my blend tree. And so now what I want to do is I want to tell it about each of these animations. And so I do that by saying, hey, this is a one-dimensional blend tree because I'm only blending on one parameter, and that parameter is vertical speed. And then I'm going to click and drag add motion field 11 times. 3, 4, 5, 6, 7, 8, 9, 10, 11. And then I'm going to click and drag all my animations in there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, and now I need to tell it at what vertical speeds do I want to transition. So I'm going to uncheck Automate Threshold, and I'm going to be at the jump 1 animation. Well, actually, I'll start up here, and I need to change these. So here in my blend tree, this is my minimum value, and this is my maximum value. My minimum value is going to be -13, and my maximum value is going to be 5. That's my vertical speed. So I'll be going 5 up or to -13 down. And so for jump 11, I'm going to do -10.8. These are things I've already determined off screen. So you're wondering where I'm getting that. That's where I'm getting that. All right, -8.11, -7.13, 6.2, negative 5.4, negative 4.6, negative 3.7, negative 2.9, negative 1.7, negative 0.03, and 2.16. These were just established ahead of time because they just look good. All right? And so, let me sum up what we've done here, because this took a while. And so basically, what we did is we said, hey, every frame, tell me what my vertical speed is, and if we jump, add some force. All right? And then in Unity, we created 11 jump animations, each one of them consisting of one frame. And in our animator, we said, hey, go to our jump and fall whenever we're not grounded. And in our jump and fall, blend across these 11 for some value of our vertical speed. So if our vertical speed is 2.6 or higher, going upwards, right, we're going to be playing jump 1. The second we're at 2.15 to negative 0.03, we're playing jump 2, and then jump 3, 4, right? So we're getting this parabolic curve. You're right, those did get adjusted. Thank you for pointing that out. Whoops, there we go. There. Thank you. Yep, that's right. Okay, and so there we go. And yeah, that shouldn't matter. Thank you. Okay, and so we got most of the negative values, only one positive value, but you're going to see this is going to work out rather well. And so I'm going to come back to my scene, and I think I've set up everything correctly, and I'm going to hit play. And if I jump, I get a jumping animation. And you can actually see here it flash as it's playing the different frames of this blend tree. All right? And here's the cool thing about this. Watch. I'm going to jump up here. Now watch what happens. I'm not going to jump. I'm just going to fall. And you'll notice how it plays my jumping animation, because it's also my falling animation, because it plays that whenever I am not grounded. So now, what I've successfully done is I've built a jump animation and a falling animation out of the same thing, right? And they both work. Now that's a lot of information, and I assure you, you may need to go back and watch this video again to see exactly, again, what it is I did. But trust me, that's awesome. Okay? So what we've effectively done so far is we've created a running, jumping, idling, animated character. And while I've done a lot of talking, and this has taken roughly an hour and 10 minutes, realistically, this whole thing could have been put together in about 10 minutes, right? Which means we can build animated characters really, really fast with the Unity 2D tools, all right? And so, really, really neat. If I wanted to do crouching, right, that's simple. I just create another state for crouching, and if I'm holding the down key, we go into the crouching state. I'll create a flag here that says crouch, true or false, right? If I wanted an attacking state, I could create an attacking state or another layer. If I wanted double jumping, all I do is just jump twice, right? It's actually pretty simple. Actually, you know what? While we're at it, a lot of people said double jumping, so check this out. I'm going to show you how easy this is. I lied about not programming anymore today, because I just want to show you this. So I'm going to say bool double jump equals false. All right, meaning we've used up our double jump. Right here, I'm going to say if grounded double jump equals false. That'll reset our double jump. This is off the top of my head, by the way. I did not prepare for this, so if it doesn't work, I'm sorry, but this is just me making stuff up. And then in jump, I'm going to say if grounded or not double jump. And then in here, I will say if not double jump and not grounded, double jump equals true, meaning we've used our double jump. All right? So if we haven't used our double jump, but we're not grounded and we're trying to jump, now we've used our double jump. All right? And so, hey, yeah, let's try that out. I don't know if this is going to work. Let's see. Play it. I jump. Yep. Okay, I do double jump. Jump. Jump again. There we go. And since our animation is based on our vertical speed, it just works, right? So look at this. I didn't even need to program a new animation. The animation works appropriately based on my vertical speed. Double jump. And I could triple jump and quadruple jump and all that crap and jetpack and whatever. But yeah, I mean, that all certainly works. How do you disable player movement until an animation ends? Are you talking about like while I'm jumping, not being able to turn around and stuff like that? Because that's easy enough to do. Check this out. In my code, if I come into this section right here, I can very easily say if not grounded, return. So this is saying, hey, if I'm not on the ground, I can't control myself vertically or horizontally or anything like that. And so if I'm not grounded and I start to jump, I can't turn around, right? I have no choice but to finish. I can double jump, but I have no choice but to finish the trajectory I've set myself upon, right? And that's more realistic. I mean, you can't obviously change your direction while you're jumping, right? And so again, that's all fairly easy to do, and the animations and the frames and all that handle it automatically, right? So very, very simple. The Animator is awesome. The Animator Controller is awesome. Animations are awesome. The 2D toolsets are awesome. I assure you all, as someone who used to hand code this crap, this is awesome. It's definitely makes things very, very simple. So, okay, at this point, I'm going to go ahead and wrap up. I did go a little bit over, but not too far. And I'll talk about the next session here in a second. So real quick, we talked about importing sprites. We talked about making sure the sprites were the right size. We talked about creating characters. Excuse me. We talked about adding colliders. We talked about building our animations. We talked about actually animating our animations using the Animator and how to create the transitions, and how to hook that all up in code. So yeah, so I covered quite a bit today. I'm quite happy with our ability to cover all of it. I was afraid we'd go too long, and I do apologize again that I didn't see everybody's questions. Hit me up on Twitter if you had a question I didn't answer it. I'm always happy to answer all your questions on Twitter. Now, I had a question about next week's session. Next week's session is kind of just a simple session where we just hang out. I don't have an agenda next week. It's right before the holidays, so I'm just kind of screwing around and punting a little bit. So I will be online next week, same time. And if you have questions, feel free to ask them. If you just want to hang out, it won't be recorded. It's just very relaxed, just kind of an end of the year type of hangout. So that being said, again, any questions, comments, suggestions, if there's more stuff you want to see, if there's 2D stuff you want to see, if there's 3D stuff you want to see, AI, any of that, suggest it to us, right? I don't know what you guys want unless you tell me what you want. Follow us on Twitter, at Unity3D, at Mike Geig, which is me, at Will Goldstone, at The Ant Ranch. Tell us what you guys want to see, and we will keep that in mind, and we'll keep creating these videos. So follow us, chat with us, whatever. If you have questions, that's a great place to ask me the questions, and I'll do my best to answer them. And yeah, and next week, very relaxed. And then we'll be skipping a couple weeks until the 13th of January, where we'll be coming back with nav meshes. So if you wanted to learn about navigation and stuff like that for AI and whatnot, the January 13th is the one to come to. So that should be everything. So thank you all very much for showing up. We had record attendance, so that's quite fantastic. Thank you very much. I will be posting link. Well, here, let me do this. So I will post a link in chat right now to the live training stuff. And if you go in there in the archive, that's where the video archive will be once I upload it, which should be here in a few hours. And yeah, and we'll get that taken care of. I'm gonna avoid GUI until we get the new GUI, which I'm not saying when that will be. But when that happens, that's when I'll cover a GUI, because there's no sense in doing a GUI tutorial only to have to redo it. So, yeah, but we will do that stuff. Always suggest it. Merry Christmas, Happy Holidays for all those who wished it to me. I wish it back. Even those who didn't wish it to me, I also wish it to you as well. And yeah, Anyway, so I'm going to go ahead and wrap up now. Thanks again, everybody, for being here and participating, and you all have a fantastic week.